Hey guys, this video is to help with the moles of ions. So I'm going to go at regular pace during this video, but I do encourage you, that's the beauty of a video, right? If you get to a point where you're like, wait, what did you say, or what does that mean? Feel free to just pause and rewind and look at that again, right? Otherwise, there are people who are getting it at different paces, and I don't want to go too slow for them at the same time. So use the video to the best that you can, kind of thing. But okay, so before we talk about this, we need to talk about something that seems unrelated, but is actually going to be related. In a single desk, how many legs are on that desk? Just 4, right? What about if we had a dozen desks? How many legs would there be? And in a quick calculation, you would say, okay, 4 times 12 desks is 48 legs, right? What about how many dozen would that be? That would be 4 dozen legs. So here's the point of bringing this up. The ratio holds constant even if you're using bunches of these materials. So for every one desk, there are 4 legs. For 1 dozen desks, there are 4 dozen legs, right? That relationship holds up. Now, what's a little bit more difficult to imagine are a mole of desks, right? You can't even really picture that. It's just a ridiculous amount. But it helps to realize that the ratio is still holding constant. 1 desk, 4 legs. 1 dozen desks, 4 dozen legs. 1 mole of desks means 4 moles of legs. That relationship will hold true regardless of which quantity word you happen to be using. Okay, so let's look at actual chemicals though. A formula unit, right? So a single formula of sodium phosphate, Na3PO4, contains how much sodium? That's going to be 3 sodium ions. That's it, right? Just 3 of them. Really tiny, like too small to even imagine. But the relationship is for every 1 formula, there are 3 sodium ions. What if you had a mole of that chemical? That would mean that for every 1 mole of Na3PO4, you've got 3 moles of Na plus ions, right? So 1 formula, 3 Na plus ions. You could use this in a conversion factor if you need to as a fraction in dimensional analysis. You could say 1 of these is equal to 3 of those. Alternatively, and what we're going to be doing more of ourselves, is saying 1 mole of this is equal to 3 moles of this, right? And it just comes straight from the formula. Don't overthink it. We just pull it right out of the formula. There's 3 NAs in there. A single formula of magnesium nitrate contains how many nitrate ions? Well, it just has NO3 is nitrate. It's just got 2 of them, right? There's a 2 out here that's describing that in a single formula. A single formula unit of MgNO3 has how many oxygen atoms? That's going to be 6 because you distribute the 2 into the parentheses. So there'd be 2 times 3 oxygens, also 2 nitrogens. It wouldn't affect the magnesium. But yeah, so that's going to be 6 O atoms pretty much. In a single formula, 6 oxygen atoms. Tiny, tiny, ridiculously tiny amount. Now, if you've got a mole of magnesium nitrate, that contains, you guessed it, 6 moles of oxygen, right? So formula unit equals 6 oxygen atoms. 1 mole equals 6 moles of oxygen, right? 1 mole of this chemical equals that. That relationship holds up, and we can use that. And again, it's just straight looking at the formula. That's where the information comes from. Okay, let's try out a couple of problems. There's 2 problems in this video only. That'll be enough to get us through. Okay, so the general process, actually. First step is to get to mole. We've been doing that, right? We've gone from grams to moles, particles to moles. So that'll be a piece of cake for you at this point. Step 2 is to find the mole ratio. That is what we just did a moment ago. For example, in Al2O3, for every 1 mole of the overall chemical, there are 2 moles of Al in there. For every 1 mole of MgCl2, there's 1 mole of Mg and 2 moles of Cl-. Just pulled that straight from the formula. That's all that came from. And then from here on out, you also want to include your chemicals with your units, which we'll see in a second. So first step, get to mole. Second step, do the mole ratio. Third step, see if you have to keep going. Let the units tell you what to do. All right, but now let's look at a problem. So calculate the moles of aluminum ions present in 163.8 grams of aluminum oxide. Okay, so first step, just like always, right? Write the given. There's our given there. That's what they gave us. From here on out, there are going to be people who try to do this without writing it out. And it's going to be to their own detriment. It's going to make your WebAssign take a lot longer. It's going to be a lot harder to do for doing that. So I highly recommend against it. I can't force you, but it's in your best interest pretty much to put the units and the chemical in your setup and actually write it out. That's going to be the most helpful to you. Okay, but yeah, so that's the big thing in this too. Before, we used to be able to get away with just including numbers and units. In every one of these problems, you're going to be switching chemicals, though. That's kind of the nature of the problem. So it's important to include the formula of the chemical that you're using in your work as well to keep everything straight. It's the best way to make sure that you're not going to make a mistake somewhere. But okay, so our first step, get to moles, right? Now it's a grams to moles problem right now. So on bottom, to make it cancel, we're going to put grams. Even if we don't know what to do yet, we're going to always bring that same unit down, right? And at the top, we know we're going to moles, right? First step is to get to moles. So remember our comparison. We know we're going to put that 1 mole on top. That's how many moles we always use when we're converting from 2 moles or out of moles. So I'm going to put my 1 mole on top. On bottom, I'm going to put the mass of Al2O3 that's equivalent to 1 mole. That's this number. That number came from the periodic table, if you remember. That's the molar mass. The mass of 1 mole of Al2O3. That is from adding up 2 aluminums and 3 oxygen masses from the periodic table. So that's where that came from. All right, at this point, we are not yet in the right spot, right? We're in moles of this overall chemical. So we have to keep going because they want moles of aluminum ions, which is different. Okay, next step, mole ratio. So I know that I'm going to bring down moles of the overall chemical because that's what I had as my last unit, and I want that gone. So that unit is definitely going to come down. I know that on top, I'm going to be comparing it to moles of what we're trying to get to. Moles of the other chemical, which is moles of aluminum ions, pretty much. The ratio is given to me in the formula. So Al2O3, for every single mole of the overall chemical, there are 2 moles of aluminum, and that's just in the formula. That's exactly where that came from. The formula says Al2O3. For every 1 overall mole of chemical, there are 2 moles of aluminum. So I put those numbers in. Okay, we're almost there pretty much. Actually, we are pretty much there. So if we look, the third step is to see, are you in the desired units yet? Which we are. We're in the desired units. They're asking us for moles of aluminum ions. So we can actually stop here. My final answer has 4 sig figs in it because the initial given value had 4 sig figs. So your final answer is going to have the same number of sig figs as the given number. We treat these other values as being infinite sig figs, right? So then that means the lowest number is the one you started with, the actual measured value. Okay. So yeah, because we were at the desired unit, no need to proceed any further. But let's say there's an important distinction here. Moles of ions is not the same thing as just straight ions. If they had asked for ions, we'd have to do something different. It's kind of like saying dozens of eggs versus just eggs. If I've got 4 dozen eggs, if they asked me for dozens of eggs, I might say I've got 4 dozen eggs. But if they said, well, how many actual just straight eggs do you have? I'd have to say 48 eggs, right? That's different. Moles is a quantity word. So let's say that they hadn't asked for moles of it. They just asked for straight up ions of it. We would just have to keep going then. So this is what your next fraction would have looked like. On the bottom, we would have put 1 mole of Al3 because we're trying to get out of moles to ions. Ions are a particle, right? So we know that our particles so far have been atoms, molecules, formula units. Ions is included in that. So that means that on top of this, we're going to put Avogadro's number. And that's how you would have done it pretty much. We didn't have to because that's not what they were asking for, but that's how you would have done it if they had asked for just straight ions and not moles of ions. So important to know that there's a difference there. Okay, so this is going to be our last problem. We're going to start with the given. That many Cl minus ions. And on the bottom, first of all, first step, right? Step 1 is to get to mole. That's our first step. So on the bottom, we're going to put Cl minus ions because we want that gone. And on top, we're going to put moles because we're trying to get to mole. And we're always going to use 1 mole on top, right? Ions, again, are a particle. So to get to and from moles from ions, we use Avogadro's number, 6.02 times 10 to the 23rd. Okay, so that is for that part. And then the next thing we're going to do is step 2 is to get to moles. Do the mole ratio. So on the bottom, I'm going to put moles of Cl minus because I want that gone from the last part. And on top, I'm going to put moles of FeCl3. And then in the formula, I see that there's 3 Cl's for every 1 FeCl3. Or in other words, there's 1 mole for every 1 mole of FeCl3. There are 3 moles of Cl minus. So I'll go ahead and put that in, put that ratio in. And now the last thing, well, actually, step 3 is to see if you have to keep going. Check if you're at the desired unit. And we are not yet because they want us to be in grams of FeCl3, mass FeCl3, and we're in moles of FeCl3. So the last step is what we've done before. Now we're just going from moles to grams pretty much. So on bottom, moles of FeCl3. On top, grams of FeCl3. We know we're going to use 1 mole because that's what we use when we're going in and out of moles. And the mass is coming from the periodic table by adding up the mass of 1 Fe and 3 Cl's, and that's the number that you get. Overall value is 10.7 grams, which has 3 sig figs because of the 3 sig figs in the original problem, in the original value rather. So that's the process. So biggest takeaways, write the unit and the chemical down so that you can keep it all straight. First step is get to moles. Right? Either going from particles to moles or grams to moles. Second step, mole ratio. Just look at the chemical formula to use that. And then if there is a third step, not all problems will have it. If there's a third step, it's getting back out of moles, either using molar mass or using particle number pretty much. All right. Good luck. Thanks for watching.